Welcome back, mathematicians. This is going to be the other part of the chapter, compound interest, right? So, compound interest is one of those things that is just a part of daily life around these parts. Uh, it, the way you invest your money and the way that you decide on where you put your money and things like that um, is one of the main reasons why compound interest is so important. This country kind of works on debt in a lot of ways. So some of you might pick up some student loans, and this, if you understand how this works, it should help you understand which loans are better than others and for why. So in this problem, I'm looking at the loss of the value of a car. It can be looked at as a compound interest problem. In this case, I'm looking at a car of $30,000 and the depreciation value is at a rate of 0.8. Okay, so we're going to look at that graph. We can pick a few points, but I think it's valuable that we look at the graph as far as a computer can draw it, right? So again, I'm going to plug in some points just to see, right? So I have y. At year zero, that should be kind of the least interesting year. I'm going to say that is $30,000, 30K. Because 0 or zero point 0.8 to the 0 power is going to give me 1. 1 times 30,000 is 30,000. There you go. Okay, to look at it, let's look at year 1 first. So I'm going to get 1 or 0.8 to the 1 power. And then I'm going to multiply that by 30,000. So let me see what that looks like. So that's going to be 24,000. So we're already looking at a loss right there. We can continue this trend, right? But we're going to see that the decrease in value happens pretty rapidly. So let me get to the graphing portion of this, and let's use a computer to graph. We can look at this graph. Actually, this car holds its value pretty well. We can see at this graph here that by the time it gets to year 30, the car isn't worth very much. Year 30, it's only worth $36. Perhaps we should zoom out a little bit so we could see how the value of this car goes down. And we can see, so this is $1,000. And by year, let's see, year 17, right? And if we look at that, so we can play around with this slide here. Year 8, it's only worth 42,000. Year 5, by year, let's go to 6. By year 6, looks like we're at about 7,800, right? And we can see that the value of this car decreases, and when it gets to, let's see, well, at year 18, you're talking almost a 20-year-old car. This thing is worth about $100 or less than $100 at that point, right? Or year 20, it's worth about 350, and then year 30, this car is barely worth anything. Can barely buy a tank of gas for that much. So we could see that this graph decreases very rapidly, right? If we zoom out enough, it almost looks like a straight line, but no, it does have some curve to it. Zoom in a little bit. So it does have some curve to it. It's just that once it gets to a certain point, it just really decreases in value, okay? Go ahead and try it this time. You should get a number this time because we have a fixed time rate, and this could be a investment of $10,000. You're going to put your initial principal in red here, $10,000. We should have some growth, right? We're expecting growth at 2%, right? So we're going to put our conversion of 2% to 0.02 in for the rate. We're going to expect quarterly growth, so every quarter, 4 times a year. So we're going to put 4s in for our ends, and we're going to see what we have in 3 years. Okay, so this is money earned, usually invested in some way or another, that we could make in 3 years if these things are true. So initial investment of $10,000, rate of 2% quarterly over the course of 3 years. Try it out on your own. You should get a number, and I'll see you at the next Ring of Fire.